Okay, it's time for our general chemistry memorization part 1 of 4. We're going to go through 4 groups of topics for which knowing things in advance is probably handy. Chemistry is full of jargon, it's full of weird terms, things like that, so let's become comfortable with them. For each of these, I recommend you pause after we state what you're looking for and go ahead and answer it and get to the point where you could go through each of these knowing all of them. Let's begin. What is an acetate? Pause the video if you need to. Now, if it's the first time, you might want to just walk through it and get to know them. An acetate. That is most commonly referred to as CH3CO2-. It's the anion from which acetic acid is derived. You might also see it as C2H3O2-, or even maybe OAC, where AC means the acetate itself. The ammonium is the only cation that is polyatomic that's common anyhow, and that's NH4+. What is a carbonate? That is a polyatomic anion that is CO3 2-. A chromate, that is CrO4 2-. Cyanide, that's Cn with a -1 charge, very toxic. A dichromate, that is Cr2O7 2-. The bicarbonate anion is HCO3-. It's derived from sodium bicarbonate, also known as baking soda, NaHCO3. A hydroxide is an Arrhenius base. It goes by the term OH-. Nitrate, NO3-. Phosphate, PO4 3-. Sulfate, SO4 2-. Sulfuric acid is derived from that. Sulfite, SO3 2-. Here's the typical columns you'll see on the periodic table. We call them groups. And the old chemists, like me, go by 1 through 8. The newer people go through 1 through 18. I think it's probably pretty likely that your professor will prefer the 1 through 8. These were intended to be the default numbers to be used. They got largely ignored. In any event, you can see that they're pretty common. Instead of 8, you'll say 18, but it's the same thing. Each one of these columns has a typical charge for any of the elements within that column. Let's go ahead and go over them. The first one has a charge of +1. It prefers to lose 1 electron. 2 is +2. 3 is +3. Hey, this is easy. 4 can be +4, but they oftentimes will share electrons, carbons in that group. Group 5, also known as the nitrogen group, goes -3. It's easier to gain 3 electrons since they have a negative charge, that's where the negative sign comes from, than it is to lose 5. Group 6, -2. Group 7, -1. Group 8, these are the noble gases. They don't tend to do anything at all. Many elements like to bond to themselves. We call them the diatomic elements. Which elements on the periodic table happen to bond to each other? This is handy. So if I said something's reacting with hydrogen, you wouldn't be thinking of H, you'd be thinking of H2. And the memorization is somebody's name. That is H. Broncliffe. There it is. H. Broncliffe, hydrogen, bromine, oxygen, nitrogen, chlorine, iodine, and fluorine. What are the most common forms of P and S? Well, P tends to be, like on the tip of a match, P4, and S tends to be S8. Just a good thing to know. Let's go through the hypofluorite, the halides, the hypohalites, the halites, the halates, and the perhalates. For each one, there's a progression. So if you had sodium hypofluorite, that would be NaFO, where Na is +1, hypofluorite is -1. When we go, so that means for each of the halogens, fluorine, chlorine, bromine, and iodine, that's what it would be. Hypoiodite would be IO-. Not very common in a stockroom. Fluorite, we gain 1 more oxygen. We're now at FO2-. Then we go to fluorite, 8, so that would be FO3 minus, ClO3 minus, BrO3 minus, and IO3 minus for an iodate. So sodium iodate would be NaIO3. Notice they all just have the -1 charge. Same thing when they're fully loaded up. The perchlorate, for example, would be ClO4 minus. Each time you just simply gain 1 oxygen. So there's a lot of answers here, but the trend is pretty clear. This is some common ions.